Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at a 2013 Hyundai Sonata. This Sonata has an air conditioning leak that as it leaks, it diminishes the performance from the air conditioning. So this is the third time that this vehicle has been returned for the same problem. So right away, what we want to do is we want to just remove any refrigerant base that's left in this vehicle, and we want to charge it with CO2. And then we want to use the Bullseye system in order to properly diagnose this car so it doesn't show up for a fourth trip back. In order to do that, we're going to hook up a recovery machine and we're going to get the refrigerant out. So let's go ahead and take care of that. We're using the shop's recovery machine to remove any remaining refrigerant out of this Hyundai. Once we've got the charge out of the Hyundai, then we can go ahead and get the Bullseye connected. We've removed the remaining charge out of this vehicle, so now we need to remove the lines for the machine. The first step that we need to do is to locate the evaporative drain hose. This hose is the drain hose for the evap core that's inside the dash. So basically, when the water drains out, it finds this low channel and then it drains out onto the ground. The CO2 is heavier than air, so it too will fall just like the water did, and it will congregate in the hose. At the end, when we pull the plug out, if the detector goes off, it's indicative that there's a leak in the evap system or something inside the dash. Now that we've got the evap drain hose plugged, we want to go ahead and we want to start the detector so it's warming up while we charge the system. So on this one, I've got a paintball can, and you can use a paintball or you can use a full industrial bottle. All the adapters are provided with our kit. The high pressure regulator that we have here will go up to 200 pounds. That's an approved pressure for all the OEs. Never ever pressurize an air conditioning system with any type of external gases such as nitrogen or helium or N2H2 or CO2. 200 pounds is the maximum. So we're going to go ahead and we're going to use the R134 adapter because that's what we have. And we want to go ahead and we want to crank this all the way tight to 200 pounds. Then we want to go ahead and let this fill. And so we're going to charge the system. Now, we've done two things right here that are crucial. One is we now have 200 pounds in the entire system. Before, you were using a refrigerant base to try to find this leak. That means that I'm subjected to the temperature of the day. It's 70 degrees right now, so that means the highest pressure I can have in this system is 70 pounds of pressure. If I was 90 degrees, I'd have 90 pounds. Now, if I start the car and run it, the low side will go to 30, and then it will drift back up to ambient. The high side, we can get a higher pressure, maybe 180, 190, but you don't want to run a car because then I've got air movement and fans and belts moving. You need dead still air when you do any type of leak detection. So no air conditioning, no fans can be turned off, everything needs to be dead still air. So I don't want to run the engine. And now by applying CO2 into the system, I have 200 pounds everywhere in this system. And now that means the low side and the high side are at 200 pounds. So I have a smaller molecule. CO2 is smaller than the refrigerant bases, and it comes out small leaks very easily. So I'll have more CO2 leaking in the time that I have my detector in front of the leak. These leaks are very small. They're not like evap leaks like a 15 thousandths leak. If I had a 1 thousandths leak in this air conditioning system, you would hear the gas escaping as a hiss, and you would lose all your refrigerant within 10 to 20 minutes. That's a huge leak in air conditioning. Air conditioning leaks are very small. Rather than like a thousandths, they're going to be 0.00000 in a number, and maybe even more zeros depending on the leak rate that's present in the system. The leak has to be present for us to find it. But the one thing is when I have more pressure with a smaller molecule, I have a way better chance to find a leak like this. So we've charged the system, and I always want to give it time, so if it's a really small leak, we've got enough time for it to start to leak. Remember, when you use your probe, move it very slowly, irregardless of what type of gases you're looking for. If you're using your refrigerant detector, or you're going to use our Bullseye CO2 detector, you need to move it slow. Very little is coming out these leaks if it is a small leak. That means that I only have several parts per million coming out. And how fast I'm going past that, if I'm in front of the hole for only a second, you didn't give the detector enough time to see the sample. You need to be in front of that hole for 2 to 4 seconds. So you want to move these type of detectors more slowly. Don't go fast. Always remember that the CO2 is going to be heavier than the air. So a lot of times, being right under the leak, the gases expelled are coming down, and I can find it as it's dropping. So these are some tips. We're going to let this charge just a little bit more, and then we're going to go ahead and start looking for this leak. The first thing we want to do is we want to set the detector to high sensitivity. Irregardless if you're using a Bullseye CO2 detector or you're using a refrigerant-based detector, always start with it on high sensitivity. These leaks are very small, and it will give you a much better chance to find it. So what we want to do is we want to check this Schrader valve. That's not leaking, so we're going to check the low pressure Schrader. It also is not leaking. So now what we need to do is we need to go around the system very slowly and find where this leak is. So we want to go ahead and we want to look around. And always remember, don't move the detector too rapidly. I'm going to check this gasket between this pressure line. On the crimp style hoses, always be at the back of the crimp and go around, and there's also a hole in these. And you want to find the hole, and wherever that hole is, you want to have the probe in the hole if possible. On some of these, you're going to need to raise the vehicle up so you can get to the bottom of the hoses. But we'll go around and we'll just double check everything real quick to start with on this vehicle. And right here you can see a hole. The holes are the best place to find the leak if there is one at the hose. Okay, and we have something getting a detection there. So let it clear. Let's just look around and let's see if anything else down here could be leaking. And see, I'm picking up that leak. This is a little bit bigger leak. So I'm picking the leak up and it makes it look like it might be the hose, but something down here is leaking. Let it clear. It appears to be the hose where it's connected to the condenser. So one way to do this is if you take some kind of like a cardboard box or a fan when you get a leak, go ahead and move the air away from it. And what then's going to happen is I'm going to be able to zero in on it a little bit better to make sure the hose up here isn't leaking first. Okay, so that makes it really difficult to tell which one of these fittings is leaking. It's going off on both of the condenser fittings. The hose could even be leaking and dropping the charge down on those fittings, and I'm picking it up from there. We also got the Schrader valve. I mean, we've got a lot of different points that could leak really easily. That's what's wrong with all the gas-based detectors. You can never really tell exactly what's leaking. What makes the Bullseye so revolutionary is the color-changing foam. I'm going to take the leak seeker foam and I'm going to spray these components and we're going to watch it. And where the leak is, exactly where the leak is going to change color from a pink to a yellow, and then we're going to know what we need to fix on this Hyundai. So let's go ahead and get the leak seeker foam and get that done. So we have the leak seeker foam, and we know that one of these fittings down here is going to leak. So what we want to do is I want to go ahead and apply the foam around these fittings, and then we're going to watch the color change and we're going to figure out exactly what's leaking here. So let's go ahead and take care of that. There it is. It's the hose. It's the hose where it comes into the head of the piece. This hose is leaking. Do you see it bubbling right there too? And you see how it's changing color? So you'll see it's pink. Watch it and it's changing color. It changes to a yellow where the leak is. This is a bigger leak where you can actually see a little bubble. Normally, it's just going to change the color. Okay, guys, so we now know what's leaking on this vehicle. The leak, what needs to be replaced, is this actual hose where the flange of the hose meets where it goes to the condenser. It's actually leaking at the point where the hose goes into the flange. This is going to be a real simple repair. This hose will need to be replaced, and then we'll get this system charged and we'll be ready to deliver this back to the vehicle owner. Now we need to check the evap core for leakage, so we're going to pull the plug out and then we're going to test it to see if there's any leakage that came from the core. As you can see, there's no leakage at this time indicated from the CO2 detector. Clearly see, the Bullseye leak detection system is superior to any other leak finding device in the world. This is a patented technology and it finds leaks fast and accurately. As you could see on this vehicle, we have two hoses, two gaskets, and flanges off the condenser. With the gas alone, any type of a gas system, this leak would be really hard to tell where it's leaking. Is it coming from the gaskets? Is it the hoses? Or is it the condenser? It clearly, once we sprayed on the leak seeker foam, you could see that the metal line is what's leaking at the metal fitting. That might not be your first thought where this leak would be. But what you think and what is what the difference is. This system shows you where it is, not what we think it is. This is the third time this car's been back to the shop because they think they find the leak. If you want to be successful and you don't want this car coming back for a fourth time to your shop, you need the Bullseye leak detector system. If you use this system, you will have good troubleshooting in your base.